Hi all, yeah, this is Riaz from Brainiacs Classes. So today we are going to discuss the chapter Aldehydes, Ketones and Carboxylic acid. Okay, so we'll be discussing the most important questions from this chapter and what else. Okay, I hope all of you are watching our Brainiacs daily capsule. So let's start with today's important questions. Okay, yeah, I hope all of you could see the screen. The question here is the reaction of acetaldehyde with HCN, okay, followed by hydrolysis gives a compound. So it will give a compound which shows what type of isomerism. This is the question. So what they are asking, let us try to understand it in detail. Okay, so you have a compound called acetaldehyde. We know acetaldehyde is nothing but CH3 C double bond O H. Okay, we know it's a aldehyde fundamentally, and this is reacting with hydrogen cyanide. Okay, this is a very famous reaction actually, which is mentioned in the text. Okay, and we know that for aldehydes generally it undergoes, or aldehydes or ketone, it will generally undergo what sort of reactions, sir? That is a fundamental for doing this question. What sort of reaction they will undergo? We can say that they will generally undergo the type of reaction that is called nucleophilic addition reaction. Nucleophilic addition reaction. Okay, so we'll try to understand how this nucleophilic addition happens between acetaldehyde and hydrogen cyanide. Okay, yeah, listen here. Okay, yeah, now let me take, yeah, so here you can see acetaldehyde is shown here. Okay, now what fundamentally these carbonyl compounds do during their normal reaction? We can say that the carbonyl group in a any carbonyl compound, for example, it's like aldehyde or ketone, we know that it is having a pi bond actually between carbon and oxygen, and we know oxygen is highly electronegative. So what it do fundamentally here is this pi bond will have a tendency to shift towards oxygen atom, because it is more electronegative, and it will undergo polarization like this. Oxygen have minus charge and carbon will have positive charge. Okay, so that means now if you see here, we know that oxygen inherently has two lone pairs of electrons are also present with oxygen. You can see that. So if you take any oxygen related compound, it will surely have two lone pairs. And now if you see the number of electrons in oxygen atom, 2, here you can see 4, then 6 and 8. Okay, so you can see here the octet of oxygen is complete. But when you are checking the carbon atom, you can see here 2, here 4, here 6. Only 6 electrons are present. Now I can say that when HCN undergoes dissociation, what will happen, sir? You will get H plus and Cn minus. Now most of the students ask me a doubt, sir, whether H plus will come and attack O minus first, or whether Cn minus will come and attack the carbon plus. Please understand, oxygen has its octet complete, so I can say that it is stable. It is stable compared to whom? Compared to carbon. Why? Because carbon has only 6 electrons in its octet. So surely first the carbon will try to achieve its octet and try to become stable. So that is the reason why always the nucleophile will attack a carbonyl group first. Please remember, this is very, very important. Always it happens like this. So what will happen? The cyanide will donate its electron to the vacant orbital of the carbon. Now you have O minus. Now in the next step, we can say H plus will attack the negative charge like this. Okay. Now it will become more stable. Why? Because this is a charged species. Even though 8 electrons are present, it is a charged species. So if it gets attracted by H plus, it will form a bond so that it will become a neutral compound like this. And this compound is called, a very famous name you should remember. They may ask it repeatedly. This is called cyanohydrin. Cyanohydrin. So please remember, whenever aldehyde or ketone react with hydrogen cyanide, it results in the formation of cyanohydrin. Why it is called cyanohydrin? Because cyanide group is also present and OH group is also present. Okay, cyanohydrin. Now they are asking in the question, if you are doing hydrolysis of this particular compound, what you will get. Okay, now you need to understand that which species out of this is capable of undergoing hydrolysis. That is the most important thing. So please understand, when you are doing hydrolysis, the cyanide only will undergo hydrolysis from the species present here. Okay, now a question comes, sir, how the cyanide hydrolysis happens? Okay, first I will tell you the shortcut. Okay, then I will tell you the mechanism. Otherwise, most of the students will say, sir, I am not interested in learning mechanism, sir. So let me tell you the shortcut, then we will go through the mechanism. Don't worry. So this is a trick you should remember. Whenever cyanide undergoes hydrolysis with a single molecule of water, what you will get fundamentally, I can say that here nitrogen has lone pair. So surely what will happen here is oxygen will not come near to hydrogen. Because of the lone pair, it will undergo repulsion. I can think like that. And we can think like oxygen will go to carbon. So you will get oxygen to the carbon. You can think like this, oxygen coming to the carbon and hydrogen coming to the nitrogen. This is not the actual mechanism. I am telling you the shortcut. Oxygen coming to the carbon and hydrogen coming to the nitrogen. Why? Because oxygen already have lone pair. So it will get repelled by lone pair from the nitrogen. Clear? Okay, so that is how oxygen coming here and hydrogen coming here. So you will get the first species. When you are hydrolyzing a cyanide with one molecule of water, you are going to get what is called amide. Please remember this trick. Now if you are going to hydrolyze this amide again with one molecule of water, again what will happen, sir? This will undergo nucleophilic substitution and it forms what? It will form carboxylic acid. Okay, so what will happen? One more molecule of water is coming means H plus and OH minus is there. So what will happen? This NH2, what it will do? This NH2 will combine with the hydrogen and forms ammonia and it gets released, and OH minus will attack the carbon, or NH2 will be replaced by OH and it forms carboxylic acid. Very, very important. So please remember, whenever cyanide undergoes hydrolysis with the excess of water, carboxylic acid would be the final product. But if they are mentioning it like maybe a single molecule of water or a 1 mole of water, then you can easily say amide would be my product. Okay. Hope you understood. And another important questions that come with cyanide is, you can do reduction of cyanide. Whenever you are doing reduction of cyanide with the stannous chloride, Stephen's reduction reaction. Okay, you can remember like that. So what will happen? Hydrogen will be added across both part of the cyanide. Hydrogen will be added. So one double bond will disappear. So what you will get? CH double bond NH. And this is called imine. So please remember, cyanide undergoes partial reduction to form imine. Now what will happen? So this is not related with this question, but I am telling this as a tip. It can come for the exam. Again, if you are reducing or a continuous reduction is you are doing. So what will happen? One more time the bond will go and one more hydrogen is added across this one. So you will get CH2, NH2. I can say you will get 1 degree amine. Very important. Okay, so that means cyanide undergoes continuous reduction to form 1 degree amine. Please don't forget this, very, very important. Okay, and the other important thing is, suppose instead of doing a continuous reduction, you are doing hydrolysis of imine. If you are doing hydrolysis of imine, again the same logic, oxygen will never go to nitrogen because of the repulsion of the lone pair in nitrogen. So what will happen fundamentally? I can think like this, listen, oxygen will come to here and hydrogen will come to here. So what will happen? NH with H2 will give you ammonia and oxygen with the CH will give you aldehyde. So please remember, this is actually the flow of this particular stuff, what I am explaining. This is nothing but the flow of Stephen's reduction reaction. So in the Stephen's reduction or the preparation of aldehydes, you can see in the first step you are doing a partial reduction that result in the formation of imine, which on hydrolysis will give you aldehyde. Very, very important. So these 3 steps you should understand. Okay. Now you can attend this question very easily. So if you see here, you can see this cyanide, it is not mentioned in the question whether they are using excess of water or not. So in that case, I am assuming there is only 1 mole of water. So what will happen to the cyanide? It will change to what is called amide. Now if you see this particular carbon, you can note that its 4 valencies are occupied by 4 different groups. 4 different groups. So I can say this is a chiral carbon, or the compound will exhibit what sort of isomerism? If there is chiral carbon, I can say this will exhibit something called optical isomerism. Optical isomerism, and that is called chiral carbon. This carbon is called what, sir? Those who are hearing for the first time, this is called a chiral carbon atom. Chiral carbon atom means its 4 valencies are occupied by 4 different groups. Such a type of compound will exhibit optical isomerism. So my answer here is, which is the answer, sir? I can easily say the answer for this question is option 1 is my answer. Okay. Now those who are interested in understanding the mechanism of hydrolysis of cyanide, they can listen. Others, they can skip it. I am not forcing you to listen to this. So fundamentally, the logic here is, I always love mechanism. The reason for that is very simple. So this is what is fundamentally cyanide looks like. You have H plus and OH minus. Now if you are thinking, you can see here lone pair is present. Here 2 pi bonds are present, and all together there is electrons are present here, pi electrons and lone pair. So there is a negative cloud is present throughout the compound. So who will attack the compound first? H plus will come near to the pi bond. We know that whenever an attacking reagent approaches a pi bond, the pi bond undergoes polarization. And we know that here nitrogen is more electronegative. So surely the pi bond will shift towards the nitrogen. So that will become negative charge, and carbon will acquire positive charge. Okay, now the H plus will easily attack the negative charge, and it will form the compound like this. You can see here. Now what will happen? Now you have OH minus. OH minus will attract it to the positive carbon, and this will form something like this. So you can see COH double bond NH. This has not still become amide. Now listen, here you can understand that here the OH group that is present here is acidic in nature. Why we say this is acidic? Why this hydrogen is acidic? Because very simple, when you remove this H plus, or when you remove this as an H plus, you can see there is negative charge coming. And we know that test for acidity is remove the H plus and check the remaining structure is stable or not. If the remaining structure is stable, I can say that particular compound is acidic in nature. So how will you check its stability? You can see here negative charge, single bond, double bond. You can see there is an conjugation happening. So I can easily say this will move to here and this will come to here as a negative charge. You can see here. Okay, so this is one of the resonating form of that particular structure. Now what will happen? The released H plus have a probability to attack the negative charge present in the nitrogen, and it will form something called CONH2. This is how amide is formed. Okay, this is the actual mechanism with which it happens. But if you are interested only, you can learn this. So others who doesn't want, they can listen to the tricks I have already explained, and they can proceed like that. Now some students may still ask, sir, we also want to know how this amide will convert to carboxylic acid on further hydrolysis. I will explain that also. So you have the amide here is present. Again, you are doing hydrolysis with the H plus and OH minus. What will happen, sir? Now you can see there is carbonyl group present. And we know that in every carbonyl group, it undergoes what? It undergoes polarization, so that the pi bond will move towards more electronegative atom. So minus charge will come and plus charge will come here. Now we know that here the octet of oxygen is complete. So surely the first attack comes from the nucleophile, that is OH minus will attack the positively charged carbon. Correct? So what will happen? OH has come and attacked and it forms a bond here. Now you have the negative charge here. Okay, and please understand the H plus will attack whom? The lone pair that is present in the nitrogen atom. So you have something like this, H plus is coming here and a positive charge coming to the nitrogen atom. Please remember, whenever a positive charge comes to the nitrogen atom, it becomes highly unstable because nitrogen is an electronegative atom. So what it will try to do, when hydrogen comes here, it will pull the electron that is present here towards the nitrogen, or the electron will shift towards this direction. And because of that, what will happen? The bond will have a strength like this. The bond would be tapered and it will try to undergo breakage. On breaking, it will move out as ammonia, NH3. And here you can already see here negative charge will move to here and you will get a carbonyl group like this. Some students may learn like this, sir, here the negative charge will come over here, it will come to form here as a double bond, then the valency of the carbon will become 5 and this bond will undergo breakage and it will form out as ammonia. You can even think like that. That is also correct. Okay. So this is how carboxylic acid is obtained on further hydrolysis of amide. Okay. Yeah. Now we go to the next question. So you can read the question. So you have here phenyl magnesium bromide. It is an aryl. It's a Grignard reagent. So C6H5 MgBr. Now it is treated with carbon dioxide followed by hydrolysis. You are getting a product P. You need to find out what is this product P is. Okay, it's a very important. Sometimes instead of carbon dioxide, they may mention this as dry ice. Because in NCERT, they are clearly mentioning dry ice is nothing but solid carbon dioxide. Solid carbon dioxide. Solid is very important. Because if it is gaseous in nature, the reaction would be very difficult. Because this is having a solid nature. Partial liquid or solid nature. Okay, now what happens? Listen, we will try to understand its mechanism. So, you have this as the phenyl magnesium bromide. Here we can say that the magnesium is an electropositive element. So, what does it will do? It will try the 2 electrons present here then move away from magnesium. Why? Because it is electropositive. It will become stable when it gives out electrons. Because we know that magnesium is 2, 8, 2. Okay, so it will try to repel the electron in this direction and that will result in a wedge shaped bond like this. Electron density is near to the carbon atom. So this will undergo breakage on heating and you will get C6H5 minus and MgBr plus. Okay, now carbon dioxide, you can see the structure looks like this. Now please understand, carbon dioxide is a temporary electrophile. Most of them doesn't know this. Why? Because the double bond between carbon and oxygen. Oxygen is a more electronegative element. So what will happen? The pi electrons will shift towards the oxygen atom because of the electronegativity. So negative charge will appear across oxygen atom and a plus charge will come across carbon atom. Now you know that opposite charges attract, so plus MgBr will move towards O minus and C6H5 minus will move towards the vacant orbital of the carbon. And please understand, here also the first attack comes from the phenyl. Why? Because here also the octet of oxygen is complete but the octet of carbon is incomplete. So surely the first attack comes from the nucleophile. So again I can say this is a perfect example of nucleophilic addition. Okay. Now let's see. You can see phenyl group is coming and donating its pair of electrons to the carbon, and in the next step MgBr is joining here. You are getting a compound like this. This is my first compound. Next, they are telling they are doing hydrolysis of this particular compound. So there is H plus and OH minus. So please remember here what is happening. The OH minus is a very strong nucleophile, and I know that here magnesium is highly electropositive. So what will happen here is the magnesium will get attracted to the OH minus and they form MgOHBr very immediately. Okay, you can see magnesium will get attracted to OH minus very fast and it will form MgOHBr, and this will have C6H5CO minus and H plus will move towards O minus. And this is how you are going to get the most important compound, that is benzoic acid. This is a very important reaction for the preparation of benzoic acid. Okay, so I can say what is the answer for this question. So my answer here would be benzoic acid. You can see here option 2 would be my correct answer. I hope it is clear for you. Okay, any doubt? Hope you understood the mechanism. So if you know the mechanism, it's very easy, sir. Please understand, in the chapter aldehyde and ketone, the reaction is always nucleophilic addition. When you go to carboxylic acid and its derivatives, always the reaction is nucleophilic substitution. That's it. Okay. Now, we will go to the next question. That is very good question. It's a conversion reaction. Okay, all of you can go through it. So they have given you phenol and they are treating this with zinc. We know zinc is a very good reducing agent. Zinc dust is especially a very good reducing agent. And the compound obtained there is treated with the CH3Cl, an alkyl halide with anhydrous aluminum trichloride. Aluminum trichloride, what is that? It's an we know that it's a Lewis acid. It's a Lewis acid. So we expect some sort of ESR, electrophilic substitution reaction here. And the compound obtained there is treated with alkaline KMnO4. It is nothing but something that performs a good amount of oxidation and followed by hydrolysis treated with H+. What is the Z? That's what they are asking. So let's try to analyze this. Okay. So first reaction is very common. It's given in the textbook. It's one of the famous reactions of phenol. So phenol, when it is treated with zinc dust, zinc is a very good reducing agent. It tries to absorb or remove the oxygen as part of reduction. So zinc oxide would be eliminated and H will be part of it, and you are getting X as benzene. So X here is benzene. You can see that is nothing but our benzene. Now in the next step, the benzene is treated with CH3Cl and AlCl3. Now please understand here AlCl3. You can see AlCl3. So I will draw Cl3 structure here. Okay, you can see here Cl3 structure, and I can put the electrons also here. Now you can count how many electrons are part of the central aluminum atom. How many electrons are there, sir? Just to count it, you will get the idea then. So when you are counting, you can easily see there are only 6 electrons around the central aluminum atom. That means it is electron deficient. I can say such compounds are known as Lewis acid. We are learning in this in the chapter equilibrium. Okay, now what does this Lewis acid do? The Lewis acid will try to break the bond between carbon and chlorine in a heterolytic way, and chlorine is more electronegative, so the electrons will shift towards the chlorine atom and you will get CH3 plus and Cl minus. And some students may ask a doubt here, sir, immediately the Cl minus can again attract the CH3 plus and they can form CH3Cl. Will it be possible? Yes, it is possible. To avoid that, we are using this Lewis acid. Why? Because the Lewis acid has empty orbital. So what it will do? It will attract the Cl minus towards aluminum atom, or aluminum will attract the Cl minus and they form a stable compound. I can say AlCl4 minus. Okay, and I can say here, you can see here, this Cl minus will react with the AlCl3 and they form what is called AlCl4 minus. This is a stable complex. Why it is stable? Because the octet of aluminum is complete now. Now we can say that the CH3 plus is the electrophile, and this electrophile will approach the benzene and it will undergo ESR, electrophilic substitution reaction, and you are getting a compound that is very famous, that is called toluene. Okay, so you are getting toluene. Now what is happening? Now comes the most important reaction, another important reaction from the NCERT itself. NCERT states that, or in any chemical books it states that, whenever there is a carbon connected to the benzene ring and if there is even one hydrogen atom that is present along with this carbon atom, if it is treated with alkaline KMnO4, it will get oxidized to respective carboxylic acid. Now we can see this is getting oxidized and it is forming COOK because KMnO4 is there, and this on hydrolysis. That's why along with that we use H+. What H+ will do? H+ will easily replace the K and it will form what is called our carboxylic acid. You can see here H+ will come here and it forms carboxylic acid, and this K combine with OH minus and forms KOH. Okay, so please remember, this is very, very, very important. Why I am saying very, very important? Because please remember, whenever there is even single hydrogen, when it is connected to the carbon that is connected to a benzene, if it is treated with KMnO4, it will get oxidized to benzoic acid. Please remember, that is very, very important. Okay. And even I can give you one more question in this aspect if you are interested, but not now. Okay, maybe we'll take it. A lot of questions are coming in my mind. Okay, so my answer here is, tell me sir. So Z here would be benzoic acid. Okay, so I hope it is clear for you. You understood the idea. Okay, now let's go to the last question. So since it is aldehydes, ketones and carboxylic acid, I cannot leave this chapter without mentioning which reaction? Aldol condensation. That is very, very important. So here I am given you a question on aldol condensation. You need to identify what is X. Okay, so please remember, if you are doing aldol condensation, one thing you can remember here is you need a aldehyde or a ketone with the alpha hydrogen. So this is my functional group that is connected to this carbon atom. This is my alpha carbon. So it should have, here it has 2 hydrogen. So here also, this is also my alpha carbon. It also have 2 hydrogen. So alpha hydrogen is present. And the other important thing that is required is a dilute alkali, dilute NaOH or barium hydroxide, anything you can use. And next thing is heating is required because it is aldol followed by condensation. So water is removed or some sort of dehydration also happens. Now I will explain you the mechanism, how this reaction happens and what would be the expected product. Okay. So in aldol condensation, the fundamental thing you need to remember here is why we say we need an alpha hydrogen minimum. The reason for that is here also the fundamental mechanism that happens here is nucleophilic addition. So here somebody should behave like a nucleophile. Correct? If you look at the reaction, there is only one compound, only one type of compound mentioned. So I can say that minimum 2 molecules are required so that one molecule should behave like a nucleophile here. So if somebody needs to behave like a nucleophile, it needs alpha hydrogen. And I can say that whenever you have a carbonyl compound is present, the nearby carbon atom, if it has hydrogen, that will be acidic in nature. Why? Because if you are removing this hydrogen as an H+, okay, you will get a structure like this. Correct? And I can say that this structure is stabilized by resonance. Why? Because this will move to here and this will move here as a negative charge. And this is stabilized by SBR, stabilized by resonance. And that is the reason why we say whenever double bonded oxygen carbonyl group is there, nearby carbon atom has hydrogen, that hydrogen will always be acidic in nature. In Malayalam we used to say one thing, this is like a puttukutti. Okay, puttukuttiയുടെ അടുത്തുള്ള കാർബണിലുള്ള hydrogen will always be acidic. This is puttukuttiയുടെ അടുത്തുള്ള കാർബണിലുള്ള hydrogen always be acidic. The reason for that is when that hydrogen is moving out as H+, you are getting minus charge, minus single bond, double bond O. So there is a conjugation and this conjugation makes the remaining structure stable through resonance. Understood? Now I can say that this H plus removal is also accelerated by the alkali. Alkali is something which tries to absorb the H plus because we know that alkali plus acid will give you salt. Okay, so this alkali, the role of this alkali NaOH is to behave like a base and abstract the H from here as an H plus. So that will result in the formation of what is called a nucleophile. And again the reaction would be similar. Why? One molecule will undergo polarization like we have already learned. Pi bond will move towards the oxygen atom and negative charge will come here and positive charge will come here. And the other molecule will behave like the nucleophile and this will attack the positive charge. Okay, so this will attack the positive charge means what, sir? This will donate its electron to the vacant orbitals of the carbon. That means there is a bond is formed between that carbon and this carbon. So surely students used to make a mistake like they will draw a parallel line to here. Don't make such mistake. Always do from negative, electrons are donated to the vacant orbitals of carbon like this. Okay, now what will happen, sir? We know that H plus is already abstracted, H plus is there in the medium. So this H plus will attract O minus and you will get OH. Now this intermediate compound is called aldol. Why it is called aldol? Because you have the carbonyl group of aldehyde. So sorry, it's a ketone, but still we say aldehyde, and we have an OH group that is ol. So ald plus ol, that is called aldol. Okay, some students used to say, sir, this is a ketone, sir. So why can't we call ketone? Please, it's not my fault. The textbook says that the carbonyl group along with OH group, we call that as aldol. Okay. Now aldol is the intermediate product, sir. Now you are doing heating. So if you are heating an alcohol, it has a chance of undergoing dehydration reaction. We know that dehydration is a type of elimination and it follows Eitz's rule. Okay, now we know that it's a beta elimination. OH group is connected to a carbon. So for me, this is my alpha carbon. I will write it, I will mark it, don't worry. So it is connected to a carbon. So this is my alpha carbon and the nearby carbon atoms. This is my beta 1. This is a nearby carbon and this is also a nearby carbon. So I can call this as beta 2 and the another nearby carbon is this one. Everybody will forget that. But please remember this is also a bond. It's not a lengthier bond. It's a similar bond like this. Okay, so this is my beta 3. Now the question coming here is, sir, this OH group will go out. This OH group will go out from, will go out with H plus from where? This have 2 hydrogen. Okay, this also have 2 hydrogen. Okay, and this carbon also have 1 hydrogen. From where the H plus would be eliminated? Again, I am telling carbonyl group is present. So the nearby carbon atom, if it has hydrogen atom, that hydrogen will be acidic in nature. Or you remember it like this, puttukuttiയുടെ അടുത്തുള്ള കാർബണിലുള്ള hydrogen will always be acidic. Okay, so what will happen, sir? What will happen? So while heating, this bond will undergo breakage. This will undergo breakage and H plus would be released here. H plus is released. And you can see here already this bond with 2 electrons are already present here. And what will happen? This H plus will have a tendency to go to a place where more electron density is there. Here only 2 electrons are present. Here 2 plus 2, 4 electrons or 2 lone pairs are present. So H plus have a greater probability to get it attracted towards oxygen atom. So what will happen? This H plus will come and forms a bond here. As a result of that, one of the lone pair of oxygen will disappear and oxygen acquires a positive charge. And because of that, the pair of electrons between this carbon and oxygen will shift towards oxygen in order to remove this positive charge, because oxygen with the positive charge is highly unstable. Because of that shifting, I can say the bond strength will become like this. I can draw it one more time. The bond strength will become like this. The more electron density is near the oxygen atom and it will undergo a breakage. So what will happen? It will move out as H2O, taking the pair of electrons from the carbon and oxygen bond, and a positive charge comes here. You can see a positive charge coming here. Then what will happen? This pair of electrons will move towards that vacant orbital. This pair of electrons will fall here or move towards that vacant orbital, and it forms something like this. You can see it is coming over here and it forms a double bond like this. Okay, so you can think like a double bond is formed between these two. But to make it more easy to see, we can just twist this compound like this, like this, like this. Then it is more easy to visualize it. Usually the option will be given like this. They are just twisting it. Okay, so this is my final product, sir. So please practice questions like this. Already for Neet, this question has already come. Hexanon. And if it undergoes aldol condensation. So please practice questions like this. This can come for the exam. Okay, this time maybe with the pentanone. Okay, I hope you have enjoyed today's session. And if you are feeling doubt in any area, feel free to comment on the comment box. And if you feel like you need an offline class, you can join our crash course. I can say very few seats are remaining. Almost the admissions are filled up very fast, and we are only maintaining a single batch, because we can give very good classes if we could focus on a limited number of students. Okay, and I may recommend like those students who have a passion to become doctor, you can approach us, because we are here to help those students who have an attitude to learn. Okay, it's not like the IQ or something matters. It's the passion and ambition that drives you forward. Okay, so thank you. Keep learning and best of luck for your NEET 2024. Keep daily learning, watch these videos, and if you feel this is worth, you can subscribe our channel.